Almost everything is entered by selecting points on the screen in COMOSYS. Whether you want to enter beams and columns, plates, bolts, rebars, or create cuts, you will be needing points to which you can snap to. Sometimes these points will be readily available in the form of snappable intersections of grids, or endpoints, and midpoints, of existing objects, etc. However, more often than not, these readily available points will not be enough to create what you are trying to create. For such situations, you will need more points. This video is to explain how you can snap to points by either creating them first, or in some cases snapping to calculated points in space without creating them. The first method, which by far gives the quickest results, is the direct entry method. Using this method, you can request COMOSYS to calculate a new point in space by using some existing snappable point. The way you use it is by hovering with the mouse above some existing point, and pressing Enter. A small edit box appears on the screen. You can enter certain shortcut formulas in this edit box to snap to new points. For instance, we can write DZ1000 here, and the command will snap to a point, which is 1000 mm in the Z direction of the current work plane from the point over which the mouse is hovering. We could also have written DX1000 to get this result, or DY1500 to get this result. It is to be noted that these distances are calculated in the directions of the current workplane. So if the workplane was rotated, they would be calculated differently. We can make good use of this style of data entry when entering inclined roof beams, for instance. Let me show you an example here. You can see two columns over here, and the height of the column is 5000. We can draw an inclined beam by simply write DZ6000 while hovering above the midpoint of the portal frame at ground level to snap to the apex point. Another formula can be like this. We can enter at 6000, 0, 1000 in the edit box. The command will snap to a point which is at a distance of 6000 in the X direction, 0 in the Y direction, and 1000 in the Z direction from the point over which the mouse is hovering. Ensure that the mouse doesn't move as you enter these formulas and press Enter. The mouse should still be hovering over the source point at the moment you press Enter. As you can see, we have entered the same roof beam as before, but by hovering over the top of the column this time. Now we can create another beam over here simply by snapping the snappable point of this created beam and column, as we already discussed before. When a command requires two or more points, and the first point has been snapped to, the second point can be calculated by using another version of the shortcut formulas. You can simply write a number like 1000 and press Enter. In this case, COMOSYS will calculate a new point, which is at a distance of 1000 from the hovered point, in the direction of the vector, pointing from point 1 to point 2. You can always enter negative numbers as well. Similarly, preceding the number with the number sign will calculate the new point by offsetting it from point 2 rather than point 1. This form of point entry is very fast, and we recommend you use it extensively. And only revert to actually creating new points where this option fails. There is another shortcut formula, which can be used in this method, is called the angle distance formula. After pressing enter to get the little edit box, we can write something like a 45, 1000. This will offset the hovered point by a distance of 1000, in direction of 45 degrees, from the current workplane x-axis. We recommend you use these direct entry methods to get used to them. Once you do, they become very intuitive and time-saving. But there will be situations when this direct entry methods fail. In those situations you will need to actually create physical points in the model in order to be able to snap to them. These commands are provided under the Edit menu in COMOSYS over here. Now let's show how each of these commands work one by one. The first command point is created by selecting this command, and click. You can see the point created here. The next command for point creation is intersection points command. This is a very useful command, which creates a point at the intersection of two lines. The user simply selects 4 points and a fifth one is created on the screen. The first 2 points selected by the user represent line segment 1. And the last 2 points represent the line segment 2. The new point created is basically the intersection of these 2 line segments. If the lines chosen are parallel to each other, no point is created. The intersection point created may lie outside the line segments, as the line segments are treated as infinite lines by COMOSYS. The next point creation command, which is available, is the divided points command. This command asks the user to select 2 points, and then divides the chosen line segment into n equal intervals. As always, the setting with which this command works, namely n, can be changed by pressing Shift and clicking the button. Once this setting is set, the command can be used to divide any chosen line segment into equidistant points. A neat trick regarding this command is to press and keep pressed any number from 1 to 9 on the keyboard, just before selecting the second point of the line segment. This will temporarily override the setting n of the command, and saves a lot of time for the user. So pressing 5 and keeping it pressed just before selecting the second point, for instance, will divide the line segment with 5 points, even if the internal setting is different from 5. Now we can divide this roof beam into 6 equal points by pressing 6 while doing so. It will put 6 points in between the chosen points of this roof beam. The next point creation command available is extension point. This too has a setting D, which can be modified by pressing Shift and left-clicking the button. When you use the command, the program prompts the user to select 2 points P1 and P2. It then creates a third point at a distance D from P2 in the direction from P1 to P2. It should be noted that setting D can be a negative number as well. So for instance, if the user wanted to create at a point, 25 mm, before this point along this line, he would press Shift and click on the command. Enter -25 as the setting. And then select any point on this line, and this 2 points creates the required point. The next point command is the parallel points command, which too has a setting D, which can be accessed by pressing the Shift button and clicking the command. This command created 2 points, parallel to the chosen 2 points, at a distance D from them. The points are created in the plane of the view in which the user is working, so the 2 points chosen must also be in the same view plane. One thing to note is that the order in which points 1 and 2 are chosen decides whether the parallel points created are to the left of the original points or to their right. The next command is the projected point command. This command does not have a setting. The user is asked to select at least 3 points. The third point, and any points chosen after that are projected perpendicularly to the line defined by the first 2 points. One powerful point creation command is the line plane intersection. In 3D geometry, a plane is defined by 3 points, whereas a line is defined by 2 points. The user is asked to select at least 5 points. The first 3 points represents a plane in space, and the last 2 points represent a line in space. If this line intersects the infinite plane, COMOSYS will create a point at that intersection. It is to be noted that after selecting the 5th point, the user can continue to keep selecting sets of 2 points, each which will represent other lines. All these lines will also be intersected with the plane, defined by the first 3 points. This command is very useful in complex geometries, and especially in the detailing of steel structures. The final point creation command allows the user to select 2 surfaces. Each surface represents a plane. COMOSYS creates several points on plane 1, where surface 2 intersects it. Depending on the geometry of surface, its extension can intersect plane 1 at more than 2 points. You can use these points according to your need. This command too can be very useful in steel detailing of complex geometries. We will use it in appropriate examples in the relevant videos. As was said earlier, all objects are created by using points. As such, the ability to be able to create points anywhere in 3D space makes COMOSYS extremely powerful. Many template-based programs only allow data entry which fits a certain pattern. With COMOSYS, however, you are not bound by any templates. If you can imagine it in 3D, you can probably create it in 3D. Thanks for watching.